Okay, this is Calc BC, Unit BC, Unit 1, Day 7, and today's topic will be inverse trig equations. So we're just going to do it on our own piece of paper. Problems after this unit. We'll start to, I'll start giving you guys handouts and stuff, but so far it's been pretty basic. Now let's just do a quick review of what inverse trig functions look like, their domain, their range, what their graphs look like. And the best way is to start with y equals sine x. In general, when we're graphing weird functions that are inverses of other functions, that's always a good place to start, is just to start with the original function. So the sine graph period is 2 pi, cut in half, cut the periods in half, go over here, cut in half, cut in half. Amplitude is 1, -1, and the graph starts at 0, 1, 0, -1, 0, and over here it keeps going. So this is the sine curve, which you guys should be very familiar with. So, all right. The domain of this graph is all reals, and the range is -1 to 1 inclusive brackets. So to get the inverse sine graph, what we're going to do is we're going to flip it across y equals x, and we're going to swap all the x and y values. So we're going to flip it across y equals x. Now, what's going to happen is that all these xy pairs are going to become xy pairs over here by switching. So 0, 0 is still going to be on the graph, but this is pi. This is pi over 2. So this is pi over 2 comma 1. So now it's going to be 1 comma pi over 2. So 1 comma pi over 2, and then pi comma 0, it's going to be 0 comma pi. And so what's going to happen is this graph is going to look like this. Now, and this is what usually happens when you reflect a graph across y equals x. It kind of looks sideways to what it usually looks like. So this, it keeps going. Now, there's some problems here because this is not a function anymore because it fails the vertical line test. So what we do is we restrict it to what we call principal values so that it is a function. So it passes vertical line test. And so we just choose a portion of the graph. This is sort of, accepted that this is the portion of the graph that we're going to accept. And this is also the way your calculator deals with it, that you're only going to get that portion of the graph for inverse sine. So this is inverse sine or arc sine. So the principal values are the angles that you can get out of it. So for regular trig, you're putting the angle in. For inverse trig, you're getting the angle out. You're trying to go backwards. And the possible answers you can get are going to be these values from negative pi over 2 to positive pi over 2. So negative pi over 2 to positive pi over 2. And that's going to be your range. So the domain, now the domain is going to be -1 to 1. And this is interesting because remember, everything that's y becomes x, everything that's x becomes y. So the range was -1 to 1 is now the domain here. So that should make sense. The range, we're not going to do all reals because it fails to become a function. So it's going to be negative pi over 2 to positive pi over 2 in radians, which is what we usually work with, but it's also negative 90 degrees to positive 90 degrees. Now, one of the challenges is to remember which quadrants it is. Now, it's always quadrant 1. always quadrant 1 for all these inverse functions, inverse sine, inverse cosine, inverse tangent. They all have quadrant 1. And then they have another quadrant touching quadrant 1 that has different values. Like this is quadrant 1. We're not going to do quadrant 2 because they're positive here. So we need another quadrant to take care of the negative values. And it has to be touching quadrant 1. So it's either quadrant 2 or quadrant 1. It's never quadrant 3. Never quadrant 3 for any of them. But it's a quadrant touching quadrant 1. So either 4 backwards or 2 forwards. But it's gotta take care of, one quadrant takes care of the positive values and one quadrant takes care of the negative values. So in this case, it's got to be quadrant 4, but backwards. Okay. So we'll do cosine x, and we'll just do this, sketch of cosine x. So 2 pi, negative 2 pi, cut in half, cut in half, cut in half, cut in half, cut the halves in half, get the quadrants, negative 1 to 1. Cosine starts here at 1, 0, negative 1, 0, positive 1. So this is the cosine graph. Okay. Now the domain is all reals, and the range is negative 1 to 1. And we're going to flip it across y equals x to get the inverse cosine graph. So here, this is going to be inverse cosine. And so we're going to flip it across y equals x. So what's going to happen is that the 1's going to be down here and the negative 1's going to be down here. And then it's going to be pi over 2, pi. It's going to be going up, negative pi over 2, negative pi. And so 0, 1 becomes 1, 0. Pi over 2, 0 becomes 0 pi over 2. Pi comma 0 becomes 0. Pi comma negative 1 becomes negative 1 pi. Negative pi over 2, 0 is going to be 0 negative pi over 2. Negative pi, negative 1 is going to be negative 1 negative pi. And so this is what the graph looks like when you reflect it. It's going to look sideways. Okay, but again, it's not a function. So we're going to restrict it to, for sure, quadrant 1, 0 to pi over 2. And then we wouldn't do this one because also, by the way, it wouldn't be a function still. So it's got to be from here to here. So the domain is going to be negative 1 to 1. The range, which are the angles we get out, are going to be 0 to pi. And that's going to be, or 0 to 180 degrees. It's going to be quadrant 1 for sure, and then a quadrant touching quadrant 1 that gives you, we don't want quadrant 4 this time because that would also give us positive values and not make it a function. So we want quadrant 2, never quadrant 3 for any of these. So those are the principal values. And then tangent. Now tangent is sine over cosine. So I don't really memorize the tangent graph or anything specifically about the tangent graph. I kind of have a basic idea of what it looks like, which is helpful. But I think of it in terms of sine and cosine because I know everything about sine and cosine. So when sine is 0, which is 0, pi, 2 pi, if sine is 0, then tangent is 0 because 0 divided by something else is still 0, right? When cosine is 0, you're getting division by 0, which is vertical asymptote. So pi over 2, we're getting a vertical asymptote. Pi over 2, 3 pi over 2, negative pi over 2. Get these vertical asymptotes. Negative 3 pi over 2. So now the graphs are going to go towards these up or down, and then it's either like this or it's like this. And I don't memorize it. Cotangent looks a lot like this too. But in quadrant 1 right here, sine and cosine are both positive, so the graph has to be here. In quadrant 4, sine is negative, cosine is positive, so you're going to get a negative. So it's got to be this, just based off of your basic ideas of when sine and cosine are positive. And so then it just repeats itself over and over again. So something like that. So that's tangent graph. So then the domain is all reals except for where those vertical asymptotes are. So except for odd multiples of pi over 2 is one way. So everything except for those vertical asymptotes, the range is negative infinity, positive infinity. It goes up and down forever. So that's for tangent. So inverse tangent, which is different than cotangent. It's not cotangent. It's inverse. One thing we can do is we could just start, 0, 0 is going to be 0, 0. Pi over 2 vertical asymptote is going to be a horizontal asymptote, right? And then you're going to, at 3 pi over 2, you're going to get a y-intercept instead of x-intercept. And then, at pi, and then 3 pi over 2, you're going to get another horizontal asymptote. So we're just, so now the graphs are going to look like this sideways version. Now, this is not a function. So we're going to pick quadrant 1 for sure, 0 to pi, and then a quadrant next to it so that it still is going to be a function. So that it's going to be that one right there. So the domain is all reals, which makes sense because the range was all reals. The range is going to be negative pi over 2 to pi over 2, but it's not, there's not brackets because, so it's quadrant 1 and it's quadrant 4, negative 90 and 90. There's not brackets because those are asymptotes, so they don't actually exist. Now, just a couple random other things. The limit as x goes to infinity of inverse tangent of x, which sometimes comes up, is pi over 2, right? The limit as x goes to infinity of the derivative of inverse tangent is 0. It gets flatter and flatter, right? Okay. So, a couple more things on the back. Now, just evaluating inverse trig. It's like work we've been doing. I mean, essentially, this is the same thing as cosine of theta equals negative root 3 over 2, and you're trying to find the angle, right? So we're trying to find the angle for inverse trig. So we do the same thing. We say, well, when does cosine equal root 3 over 2? Ignore the negative. You say, well, 1 root 3 over 2 is that first angle, pi over 6, or 30 degrees. What quadrants is it negative in? Well, quadrant 2 and quadrant 3, and usually we do all these answers, but since we've been given inverse trig, that's different, and that means we need to do principal values. We should only be getting one answer, okay? So it's never quadrant 3, so it's got to be quadrant 2. And then so the answer is quadrant 2. So that'd be pi minus pi over 6 would be 5 pi over 6, or 180 minus 30 is 150 degrees. So, we could do another one. Inverse sine of negative 1/2 equals. So then we could say, okay, well, what's alpha? When does sine equal 1/2? That first angle, 30 degrees, pi over 6. When is it negative? Quadrant 3 and quadrant 4, but it's never quadrant 3 for principal value, so it's got to be quadrant 4. So then you might think, okay, well, that'd be 2 pi minus pi over 6. That'd be 11 pi over 6. or 360 minus 30 is 330, which is what we usually think of for quadrant 4 kind of first, but that's not right. We got to go into quadrant 4 backwards. So it's got to be negative pi over 6, negative 30 degrees, which is different. It's another quadrant 4, but there's infinite quadrant 4s. Okay, here's another one. Okay, so here's the deal. We got to try and find this angle, and then we're going to take cotangent of that angle. But here's the deal. That's not one of the angles we memorized. So we're going to try and draw a picture here. Now we know sine is opposite over hypotenuse, and the negative doesn't necessarily belong to the top of a fraction. It could come from the denominator, but we know that the hypotenuse is always positive, so it's definitely the opposite side. So which quadrants could we have a negative opposite side? It would have to be down, so it's either this one or this one, right? It's either quadrant 3 or quadrant 4, but again, we're doing principal values here, so it's never quadrant 3. It's got to be quadrant 4. So this is your alpha. This is your angle, theta. And so for cotangent, which is 1 over tangent, with tangent sine is sine over cosine, or tangent is opposite over adjacent. So this is going to be adjacent over opposite. And so this is the adjacent side right here, and this is the opposite side. So we need to do a little Pythagorean theorem to find the adjacent side. X squared plus negative 2 squared equals 5 squared. X squared plus 4 equals 25. X squared equals 21 square root plus or minus. Now plus or minus because this one is positive square root of 21. This one would have been negative square root of 21, but we're not going to do that one. So we're going to do adjacent square root of 21 over opposite, which is negative 2. Now, usually for a final answer, just put the negative in the top or in front. But so we never actually had to find the angle. We just did a little picture. Here's an interesting one. Sine of inverse sine of 2/5. Well, guess what? It's going to be 2/5. They undo each other, right? Inverse sine of root 3 over 2. Alpha equals that further angle, 0, 1/2, root 2 over 2, root 3 over 2, pi over 6, pi over 4, pi over 3, or 0, 30, 45, 60 degrees. And it's going to either be quadrant 1 or 2. It's always quadrant 1 for principal values. So it's going to be pi over 3 radians or 60 degrees. Okay. We have a one-to-one function. This is just another topic. So 1-to-1. And what that means is that there's 1 x to every y and 1 y to every x. It's kind of like the definition of a function that says every input has exactly 1 output, but then it takes it further and says every output has exactly 1 input, which is not always usually true. So it passes a vertical line test. Every input has exactly 1 output, and it passes a horizontal line test. Every output has exactly 1 input. So that's another way of thinking of it. So here's a couple examples here. So you could have something like a parabola. This is not 1-to-1, okay, because it fails a vertical line test. But another example is a cubic. Kind of looks like that. And that is a 1-to-1 function because it passes vertical line test anywhere. It passes horizontal line test anywhere. So the answer is yes, that is 1-to-1. Monotonic, which is kind of related to this, is always increasing or always decreasing. So you can tell that this one's always increasing, right? Can't be increasing and decreasing. Okay, cannot be that. Anyways, just also another little quick derivatives of trig, just to add these, just to refresh our memory. Y equals sine x, the derivative is cosine x. Y equals cosine x, the derivative is negative sine x. Y equals tangent x, y prime is secant squared x. The inverse of sine, the derivative is kind of weird, isn't having trig. It's 1 over the square root of 1 minus x squared. The inverse of cosine is actually the same thing, 1 over the square root of 1 minus x squared with one small change. It's a negative. Remember, all the cos have negative derivatives. Inverse of tangent, y prime is 1 over 1 plus x squared. Anyways, that's just some quick reminder. And so you have a homework assignment today, so you're going to try that. And this is the last lesson of Unit 1 of our review unit. So we'll probably pretest soon, and that's it.